Okay, when we use anti-differentiation or integration is to find our area under curves. And now, there's a couple of ways you can approximate these things. So that's what they originally started doing. That's one thing that you're going to have to know. So to approximate the area underneath a curve, what they do is they can use a series of rectangles. Well, before they learned to integrate properly and differentiate properly, they had to approximate. So one thing we have is a left endpoint rule and a right endpoint rule. So for the left point rule, we have this. The first column starts. The left of the first column starts on the function, whereas for the right endpoint rule, the right side of the first column starts on the function. So here we're starting on the left, here we're starting on the right. And to work this out, what we do is we approximate the area with a series of rectangles. So this is how we end up having to do it. So we know that each of the rectangles has a width of a half. So we're going to start with the left end point. So they've all got a width of a half. 0, 0.5 to 1, 1 to 1.5, and so on. So that's what we've got as all of our widths. So all we have to do is find the heights, and then we add them all together. So if we're at 0.5, and we're trying to work out the height there, we have 1 over 0.5. So that gives us a height of 2. So that's where we're at there. So that's at a height of 2. Now for this, we're at 1 over 1, which is 1. For this one, we're at 1 over 1.5, which ends up being 2 over 3. And then for this point here, we are at 1 over 2, which ends up being half. So what we do then is we add up all these areas. So we multiply them all by half, or we can add them all up and just use and just expand that. So if we go 2 plus 1 plus 2 over 3 plus 1 over 2, and we multiply all that by a half. We end up with 1 plus a half plus 1 over 3 plus 1 over 4. And we can simplify all that down. We can add that up to find that we end up with 25 over 12 square units. Now, with the right point, look at that point there. So we have our function, 1 over x, so it ends up being 1 over 1. Here we have 1 over 1.5, which ends up being, like we said before, 2 over 3. Here we have 1 over 2. And then for our last point, we have 1 over 2.5, which translates to 2 over 5. So the same deal goes. They're all a half, so we add them multiplied by half. So we've got 1 plus 2 over 3 plus 1 over 2 plus 2 over 5, and multiply that by a half. So we get a half plus a third plus a quarter plus a fifth, and from there we find that all of that equals 77 over 60 square units. So that's how we go about the left point and the right point. So just to recap, for the left point, the first column, the left side of the first column touches the function, and for the right point, the right side of the first column touches the function. To find, we're always given a width, a half in this case, and to find the height, we just substitute this into our function. In this case, it's 1 over x.